Well, this is my solution to what to do with all the wood that I've been chainsaw milling. If you saw some earlier videos, I've been into chainsaw milling for a while, and I needed something that would help dry the wood but also sanitize it and kill the beetles. I've learned from my mistake. I was given some wood years ago. It was just air dried, and I didn't really think that much about it. I mixed it with some of my already kiln dried wood, and next thing you know, I'm seeing little sawdust piles coming out of it. And I realized I had such a problem. And at that time, I went ahead and looked into eliminating it from my wood storage. And I thought about the borax route, but there's no way I could do 1,000 board feet with borax. It would be way cost prohibitive. And so I looked into the international standards of how to sanitize like the pallet woods and stuff coming in, and they suggested 133 for so many minutes, and it's not quite the same standards we have for wood kiln. But I'm not actually drying in a kiln wood that at that time. This was just getting it up there nice and hot. In fact, I built a real simple kiln that didn't hold that much wood. I had to continuously repeat, take it out, put a new in, and that was just all a lot more glass, insulated walls, no ventilation at all, and fans circulated. And to make the long story short here, I've had zero problems with all that wood I put through there. Now there were a few boards I just had to burn; they were just beyond the pale. But that took care of that problem. I've actually built a different wood storage unit over here, and I can kind of keep an eye on all the wood, and I've never seen a single indication of any powder post beetles, so I'm happy with that. So I've learned from my mistakes and realizing that air drying is just not good enough if you want to really protect this stuff from powder post beetles. So this is what I came up with. And anyway, now in the background here, this topper is filled full of wood. That's a different wood storage system. That's just for storing firewood. That's about 30 feet away from here. But this is what I came up with. This is one in the front here. Now I got these windows um, at the university I was working at. They were tearing down one of these dorms, and they were just breaking the stuff up with aluminum. And I was able to buy quite a few of these windows for really next to nothing. And these were some of the bad windows. Something was wrong with them, all dented on the inside, and perfect place for this. And really, what they were just was a cheap source of single pane glass. Now the construction here, all I did was dig the footing, filled it up full of crushed limestone, set a bunch of cinder blocks also on the perimeter, also some in the middle to support the wood. It's actually made with pressure treated ground contact plywood on the bottom. The side walls are just normal plywood. And then I skinned the whole thing with aluminum because there's no way I've never been able to finish aluminum well enough, and this was a fast and cheap and I think a real long-lasting solution. So this should last a long time, even though it wasn't really concrete base and all that type of stuff. The whole thing is powered with 100-watt photovoltaic panel that powers the communication inside and the fans, and I'll get into that a little bit as well. But so this is the outside back. Now this is more of the skins. Now there's actually 4 panels here. All these panels come off. That gives me complete access to the inside. But I didn't want to be hitting my head or hurting my back loading this thing up all the time. So what I did, I made it so the roof would raise up, giving me complete access to it. And like I said, the whole back comes off completely. Now, also what I really recommend if you go this route, I built these little bars. And I'm really glad I did because I think I would have already busted one or two windows loading this thing up. Because when you put wood in here, one in, then you slide the other in, sometimes they will pivot. And what happens, it'll pivot into the bar instead of the glass. So I'm really glad I did that. And that was something you really must do if you're going to go this route. It really helped me protect. I sticker the whole wood up, of course. Now, what I used to raise this roof up here, and I'll get into that, but I had these linear motors here that used to be used for the old style huge satellite dishes to move them around. And I got a couple of these at a ham radio fest, I don't know how many years ago. They've just been sitting around waiting to be used on something. And I thought, well, hey, this is the place. because I tried to make this roof as light as possible, but it's still, with the metal roofing in there, it got heavy enough. And I figured, nope, I need something that's going to lift up, but also keep it from going all the way over. And then that was actually the role of these linear motors. This is it from another view. And like I said, it all opens up and all the stuff can be taken off. It really is, I can take everything out of here, and this thing really could be moved even if I really wanted to, or it could be repaired as well. Anything in the ground is ground contact. This plastic you see here, that's just a moisture break from between the cinder blocks, just to keep any moisture from wicking up. And there's lots of wood underneath the plywood here just to support these beams here, because there's a lot of weight in this, so I want to make it strong enough. So really the cinder blocks hold it, and it's got pretty strong wood. Now this is an earlier picture with the battery inside. When you get to the sanitation temperatures, that temperature will destroy a battery pretty quickly. High temperatures are not good for batteries. It's chemical reactions, and they will actually work so much quicker. So yeah, I have removed the battery since then. So this is the other view, and like I said, this is why I use the aluminum flashing, because there's just no way I've ever got it to be able to finish plywood. It just doesn't stick. And that aluminum is really quick. Yeah, it has a little wrinkle look. It's never going to look like an Airstream, but I don't care. It protects it. I did manage to, well, I borrowed something from the aircraft wing, and I'll show you as this opens up. This is running at 3 times normal speed. It's slow, it's sane. It does have a little curve to the roof, but when I built this thing, it had a nice curve to it, but it matched up so well below, I left that curve right into it. In fact, all these panels have that same curve, so each panel has a unique spot. This panel actually just clips on with magnets right here, and the other panels have internal. I have to kind of turn them and unclamp them to open that up. But you can see the roof here is a lot like an aircraft wing. I used well, this is a real good plywood, 1/4 inch plywood or 3/8 something. It's like 5 ply, and it's really strong for its weight. And I use this because, one, it reduces weight, and yet it's still nice and strong. It is secured both on both ends as well as the middle to keep them from folding, and I've had no problem, and I really don't think it will be a problem. Now, I didn't use any special controller for these motors. In fact, all I have to control the motors up and down, I'm using 2 of these double pull, double throw switches. These are the ones that actually have a center off, one way on, one way off, and that's a double pull system. And you can use those things. And well, I have this mess of wires right here, and I'll explain that. Here's a schematic of what I did with those wires. You know, I got positive and ground. The batteries can be, the switches can be wired up the same way. But here, if you follow the positive with the switch down or switch up, it makes no difference. The positive is going to be here, down the positive on the bottom side here. If you flip the switch around, now the positive is going to be in the top part of the output of that switch. So it gives you the ability to control polarity, reverse a motor, just with a simple double pull, double throw switch. Of course, this is just one switch. You're going to need 2 of them for 2 motors. But that was a simple thing. Now I did weld up some 1-inch square tubing. This is where it pivots on. Now the bottom of this arm of this linear motor does swing around, so you got to make sure it's clear. I did use here for my outer vents on the side. These are just dryer vents. I put different vents in the back frame there, but the dryer vents just help the air transfer. The one on the other end actually has a fan in it, which can blow in and help the air exchange if the temperature and humidity is correct. The top part of the linear motor, I just welded up a piece of angle iron, welded a bolt onto it, and that's it. It's a friction nut, so it won't come off. This other piece up here, I used to have another system that actually would lock it in place, but I don't need that anymore. let's see here. I just used door hinges. I had a bunch of leftover door hinges in my hardware container, and so I used them and put them on top of the aluminum flashing. And I actually kind of got the aluminum flashing so it's always going to shed the water off. And even the outside aluminum here, I made that a little bit longer over the lid so it overhangs this area. So again, it's kind of a drip edge and water won't come in. I've had no problem with water for 2 years now. So knock on wood, knock on dry wood. Now to make these ribs for the roof, I actually use my Maslow. Maslow CNC is a wonderful organization, wonderful machine. I really like it. And this is the first project I use FreeCAD for. I used to use Fusion 360, the free version, but I got tired of being hounded. You got to renew all this type of stuff. Anyway, it wasn't me or them. It was them. I use FreeCAD now, and I really like that. That's a wonderful program. This FreeCAD is actually the first time I used it in this machine to, or this project, to actually design the pieces, but also then generates the G code as well. And again, a Maslow CNC or any CNC, if this is just a one-off, I would probably just be whittling that around with my bandsaw. But since I needed so many of these identical pieces, well, that's where Maslow rules. You can just crank them out as many as you need. So this is again another picture of it all opened up as loading. There are some little holes, and actually there's some 1/4-inch studs here in the bottom that those wall panels just kind of lock into. So the whole thing keeps it from locking in. So it's just been working great. I have no problems. I have these vents in the panels. What I did, I designed these things and built. These are 3D printed PETG. Inserted a 1/4-inch anti-mouse blocking system here, rodent blocking system. Now I made this little lip here so I can attach just a small piece of aluminum if I wanted to extend that for like a rain block, but I've never had rain in here, so I'm not really too concerned with that. On the inside, I can actually slip a piece of aluminum I just got bent and right in this little groove right here, and that will block it off. In fact, when I went into the heating of this to sanitize it, I closed off everything, tried to get it as hot as possible. Now this is what I'm using. I use a Jenison solar charger. This actually handles all the, it won't overcharge the battery, and I really like these Jenison things. They're just rock solid. Off switch, fuse protected. This is the fan that will exit. There's enough fan in the bottom here that just circulates inside. That fan on the inside, that runs anytime it's above 70 degrees. It just circulates. Got a little fan inside there. I got a couple little buses just to make things easier to hook up. Now I needed some microcontroller to run this thing. So I've been playing around with these ESP2866s, these Node MCUs, and I really like them. They're really simple to use and they're cheap. They're not near the power of an Arduino. You're limited in the number of pins you can use, and also there's many pins you can't use. If they're high or low at boot up, they just won't work. But on this system, they're powerful enough. I'm running two of the DHT. This is the temperature humidity sensor, DH222. I'm using two solid-state relays. This is what I use to control the fans on and off. And then I have a voltage divider, two resistors put in series, and you just measure the voltage of the middle, and that will give you the safe voltage, because these things only run 3.3 volts. So with the voltage divider, you can get that down to a reference, basically what the 12-volt battery is doing, and I feed that output right then to the analog pin. There's only one analog pin in these things, but it works fine. This little white thing down here, that's the DH222. There's another little board on this. This is kind of a hand-me-down from another project. I'm not really using this other little sensor down here. That was a organic compound. So this is a simple thing, and like I said, I like these ESP2866s, but there's no socket available for these things. They're odd size. However, since I can make my own printed circuit boards, it makes it simple. And really, I will post the artwork of this project if anybody wants it. In fact, I can even post the code. It runs an Arduino, and it was a pretty simple project, really. And what's nice about these, the nodes here, is that I don't need a display because it's hooked onto my Wi-Fi. This is actually now HTML to my phone, iPad, I mean, or even my computer. I can pick it up since it's got Wi-Fi on it. And this is the display that I get on my, I think this is my phone. Could have been the iPad, but it makes no difference. This is what it was on Wednesday, August 23rd last year. And the inside temperature measured 141 degrees. Outside temperature says 105. It's probably closer to 98, but because of where the sensor was, hot and shiny metal, it was pretty hot. It also registers what your high temperature is. In this case is the highest I've ever recorded. I had several days prior to this though, 135, 140, 139. So now what I have this thing set up, nothing like that internal fan is going to run until at least gets 70 degrees. And it's got to be at least 4 degrees hotter inside than outside for it to run. The inside humidity is 32% of this, and the outside humidity is 59. That's air, of course. And it won't trigger that air exchange fan until at least the humidity inside is higher, at 2%. And this hardly ever runs. If I put fresh cut wood in here, yes, it will run because the humidity is way high inside. But once it starts going down, that fan hardly ever runs. It tells me the fan status, whether they're running or not. These are both off at the time. And also it gives me the battery voltage. Because I can take that analog output from the voltage divider and then remap that on the 3.3 voltage across the range. And it will give me, and I can measure that exactly and kind of how I map it. It comes out to a pretty good approximation of what the battery is. And then the low voltage cutoff, if that battery, say we have many cloudy days or something, and the voltage battery drops down below 7, it won't turn the fans on, it won't do anything, it just won't deplete the battery. Now, this is what I had after my very first year. I was kind of shocked. I was shooting for 8%, and the wood here came in at 5.2%. And I thought, wow, that's drier than I really wanted. But on the other hand, I wanted dry wood because that's another way of eliminating the threat from the powder post beetles. So not only the heat, but get them nice and dry. Now I have, on that wood, I have taken it out and separated that from my main wood supply just to make sure nothing's growing in it. But I also needed to get it to kind of stabilize the wood a little bit higher. That was pretty dry. It's like living in Arizona or something dry, but I don't think that's a problem with the wood. I've used some of it already for some trim work and had no problem. In fact, it's gorgeous stuff. So now to sanitize it, I had built this little tracking system a couple years ago to heat my back room, my office, and it also cools it. I have a Peltier effect air conditioning system now running on this system. This will track it and gives me it's supposed to be 500 watts something will put out. But this is actually from another video. In fact, if you want, this is an excerpt of that video. If you want to watch that, it goes in much more in detail of what it is. But this is directly being fed from those solar panels into these resistors here. Now that's the temperature sensor. Yes, it's close to 600 some odd degrees. The other one's basically the same temperature if I get it positioned correctly there. They were enough to create a chimney effect, and I have a pretty good stream of warm air coming out this to heat my back room. Now this is long before I cleaned up my back room here. But what I did, I took these tubes and put them in the kiln. Okay, and because on the back room where these tubes are now and currently, they just plug into this receiver right here. I just got this. This is what I'm using to plug these heaters in. And what I did, I unhooked my the solar connectors from my panels and made a little device so I can plug into extension cord. Now the extension cord goes over to the solar kiln, which is probably 30 feet away from this tracking system. And I just ran that extension cord into the building, and then I built this little thing which I can plug the heaters back into, and I had those two heaters inside of the kiln also generating their heat. And also what's not pictured, I didn't take a picture of it, but I got some of this 4-foot aluminized mylar. And what I did, I put a long pipe right in front here and a couple pipes on the side here, just temporarily, just for a few days. I used some clamps and just clipped that mylar on the front of this thing, 4 foot by 12 foot or 14 foot long here, and that actually added the solar reflector. So all that heat was actually hitting is now being reflected into the solar kiln. So that's how I boosted my temperatures to that 141 degrees. Now, I had found this ISPM, which means something I don't know, 15 regulations that requires pallets and everything being shipped internationally has to meet these standards. It has to kill the bugs, otherwise you'll be importing bugs in the pallets with whatever else you're importing. And this is what I used to sanitize my 1,000 board feet of wood when I was infected earlier on with the powder post beetles. I've had no problems with this. I know people who operate kilns and things like that have a lot higher temperatures there too, but I think they're trying to get it done quickly. And I can let this last for several days. In fact, like I said earlier, that 141 was just a high temperature that day, and it was probably 130 for over a week. And so yeah, we had some good hot temperatures there. And like I said, I've had zero indication of anything growing there, so I'm real happy with that. Now, the problem I had, and if you go down this route, the kiln's a long way away. I needed to have it connected with Wi-Fi. So, and the shop I'm in here right now is also several hundred feet from my house and way beyond the range of the Wi-Fi. So what I did, I put up this easy bridge. This is a microwave bridge. Basically, it acts as a long Category 5 cable, but it's linked with a microwave instead of the actual cable. This is done by Tycon Power. It's been just plug and play. There's a receiver on my shop. I got another one on the house way over there. And these things are good for several kilometers. In fact, I've got this power really reduced so my neighbor doesn't get into it again. But that allows me to then connect to the Wi-Fi here. Now the problem I ran into is that the Wi-Fi in the house had a router out there, and what I really needed to have was just one gigantic Wi-Fi network. And so what I did, I had an older router that I replaced. I set that up in this building here, and I put it into bridge mode. And with a bridge mode router, it really just kind of expands it, mimics it, same path code and everything, so same name. It just acts as one gigantic Wi-Fi network now. And what I was curious about, because I used aluminum flashing on the kiln, I thought I would have a Faraday cage, and thinking, well, the Wi-Fi signal might not be able to get through there. Not a problem. So anyway, I was real happy how well it's turned out. It's been this batch of wood here will be done sometime this late summer. I'll be checking this one a little bit earlier. I don't know if I'll still take it down to 5%. We'll see how the cherry works. Cherry is very stable. I've not really worked with that much ash here. But again, I was just devastated by the emerald ash borers, and we lost so many trees here. And this was a gorgeous tree that just up and died, and got several dozen more. So anyway, that's my solution to what to do with all the kiln. And by the way, this is the panel I had in here, this little piece of wood here. I had originally set a small photovoltaic panel inside here, and that just ran the fan. In fact, that was the same panel I used to run my fans on the original kiln I had. But when the temperature hit 140 some degrees, I looked in there, and that particular photovoltaic panel had spider webs of cracks all over it. The heat was just too much for it, and so I really kind of trashed that one out. It wasn't an expensive one, but still, it was, I didn't want to destroy it, which I did. So yeah, you got to be careful. That much temperature, and um, that's why you see the batteries now on the outside over here, out of the way. But anyway, this has been a great solution to me. If it helps you, well, great. So hope it does help. Anyway, have a good day.